Welcome to Decoding Complexities. I'm Pradeep. Imagine we have built a robot. Its job is to place an object on a target, but its first few attempts are not great. It's off by 10 centimeter, then 5, and then it overshoots by 8 centimeters. As an engineer, we have a critical problem to solve. How do we teach this robot to get better? Before we can teach it to improve, we first need a way to tell how wrong it is. We need to give it a score. In the world of machine learning, this score has a name. It's called a loss function. And it's the single most important concept for understanding how an AI actually learns. A loss function is incredibly simple at its core. It's just a formula that calculates a score telling us how far we are from the target. A low score is good and a high score is bad. The entire goal of training any AI is to make this loss score as close to zero as possible. There are different ways to calculate this score, and the method we choose can completely change how AI behaves. Let's look at the two most important methods for regression problems. The first method is the most intuitive, mean absolute error, or MAE. We simply calculate the error for every attempt and take the absolute value to make sure it's always positive, and then find the average. It's the honest, straightforward average error of our model. Think of MAE as a manager who treats all mistakes equally. Missing the target by 10 centimeters is simply twice as bad as missing it by 5 centimeters. It's fair, linear, and very easy to interpret. But what if big mistakes are really bad? What if missing by 10 centimeters breaks the entire machine? This is where mean squared error, or MSE, comes in. Instead of taking the absolute value, we square the error. Look what happens. By squaring the error, we are punishing our model for large mistakes far more than for small ones. An error of 10 is now seen as 4 times as bad as an error of 5, not just twice as bad. Think of MSE as a strict manager. It forces the model to obsess over fixing its biggest blunders. This is also the most common loss function in machine learning because it creates a smooth, bowl-shaped error landscape, which is perfect for optimization algorithms like gradient descent to navigate. So, which one do you choose? It's a critical engineering decision. If we want a model that is robust to outlier data and gives an honest, interpretable error, then MAE is a great choice. If we need a model that aggressively penalizes large errors and we want a smooth path for optimization, then MSE is the standard choice. The loss function is your AI's guide to the truth. It's the GPS that makes the entire learning process possible. Now that we know how to measure error, we are finally ready to build the machine that minimizes it. Make sure you're subscribed because in our next video, we will build a linear regression model from scratch using mean squared error as our guide. Thank you for watching.